In a general elimination reaction, we have the loss of an element and then the formation of a double bond. This is done by the deprotonization of a leaving group and the ionization of a base with a beta hydrogen. This allows for a double bond to be formed between the two carbons using the extra electrons. This animation is showing the mechanisms of an E1 reaction. The molecule being used as a substrate is 2-bromo-2-methylpropane. This is a tertiary substrate and works best with an E1 reaction. This has to do with the stability of the carbocation. A carbocation with 3 methyl groups surrounding the positive carbon center, is more stable than a carbon center with just 1 methyl group. Most of the time, a primary carbocation is too unstable to form. The leaving group is a bromine ion. For an E1 reaction to take place, the leaving group has to be a very strong acid. Bromine is a large element, so it can leave very easily. Once the leaving group leaves, a base comes in. The base being used in this animation is NH3O. This is a weak base and causes an elimination reaction to happen. The base has to be weak in order for a carbocation to be formed. If the base was strong, this would be a concerted reaction, and that is an E2 reaction. During this step, rearrangement of the carbocation can also occur. A methyl shift or a hydride shift can happen in order to make the carbocation more stable. Now that the base has arrived, it can attack the beta hydrogen. Beta hydrogen are the hydrogens adjacent to the carbocation. The hydrogen transfers its protons to the carbocation and forms a double bond. There is no longer a positive charge on the molecule, and it has become neutral again. The base is positive because it took on the extra hydrogen, and the bromine leaving group is negative because of the ion formed. The products of an E1 reaction are mostly Zaitsev products. This is because it is the more substituted of the two products, meaning it is more stable. E1 reactions always produce a Zaitsev product because of stability, and the base characteristics have no control of arrangement like in an E2 reaction. E1 reactions can produce both the cis and trans product because it is stereoselective. This means that the product does not depend on the substrate for its positioning. This is possible because of the possible rearrangements that the carbocation can have. However, the trans product is more likely because it is the most stable. An example of a real-world E1 reaction is a dehydration reaction. A dehydration reaction happens when there is a hydroxide group on the molecule. Hydroxide is a very strong base, meaning it is a very poor leaving group. Before it can leave, it has to protonate with an acid like phosphoric acid or sulfuric acid. The acid is able to react with the water in the solution and is able to form a hydronium ion, which reacts with the hydroxide to form more water, which is a good leaving group. The water can then leave and the reaction can continue on like any other elimination reaction. In some reactions, water is also the base that attacks the beta hydrogen, forming the double bond. Water is very important in these reactions because it can act as the leaving group and the base that attacks the beta hydrogens. Now just a basic summary of E1 reactions. Tertiary substrates are preferred because it can form a stable carbocation. You need to have a strong leaving group and a weak base. The reaction is only stereoselective, and most of the time you're going to have the Zaitsev product or the major product when you have the regiochemistry. It works best with ionizing solvents, and there can be rearrangement during the carbocation stage